All right, continuing our test 4 review, we're going to do questions 14, 15, 16, and 17 in this video. So this one is an application of exponential functions. It says the amount in grams of a drug in the body t hours, so t is playing the role of x, but t is time, so that's why we use t hours after taking a pill is given by this function. It's an exponential function. We see the t that is in the exponent. A of t is equal to 50 times 0.76 raised to the t power. And the first question says, well, what is the initial dose given? Remember that the initial dose is that would be like the starting value, initial meaning starting. And remember that the starting value is the number that's in front of the growth factor. So in this case, that's 50. So this is the initial population. We could call it a population, but really it's a dose because it's a drug. So the answer to this question is 50 grams. 50 grams is the initial dose. And then it says what percent of the drug leaves the body after each hour. That's asking about the growth factor, 0.76. And we know that the growth factor is equal to 1 plus R. And in this case, the growth factor is 0.76, so that's equal to 1 plus R. So if we subtract 1 from both sides, we get R is equal to negative 0.24. Now the negative is irrelevant. That just refers to the fact that the drug is leaving the body. We really care about the 0.24. So R is 0.24, but it's asking for a percent. So we need to multiply the 0.24 times 100 to turn it into a percent. And that gives us 24%. So what percent of the drug leaves the body after each hour is 24%. What is the amount of the drug left after 5 hours? Well, all this is asking us to do, 5 hours is a time. It's just asking us to plug 5 in for t. And so it's going to be 50 times 0.76 to the power of 5, which can just be plugged into a calculator. So we'll go 50 times 0.76 to the power of 5. Enter, and we get 12.678. See, this says 677, but this next 6, the fourth number is a 6. That rounds a 7 up to an 8. So 12.678. So 12.678. And it's the drug, so how much of the drug? The drug is measured in grams, so it's 12.678 grams are left in the body after 5 hours. Now let's look at question 15. It says, how much do you need to invest in an account earning an annual interest rate of 6.7% compounded annually so that your money will grow to $80,000 in 35 years? Okay, so it looks like the money's going to grow to become 80,000. That sounds like an ending value. 35 years, that sounds like a time, so that's t. And 6.7%, that sounds like a rate. But to find out what the rate is, we're actually going to have to divide the 6.7 by 100. So 6.7% divided by 100 is 0.067. So our rate is 0.067. Our time here is 35 years. And it sounds like this 80,000 is the ending value, okay? And so that's going to be the amount of money after 35 years. So we would say M of t, but t is 35. So M of 35 is 80,000, okay? Or we can just say ending value is 80,000, okay? So we know that the way the formula works is we have a starting value, so starting value times, and this is not continuous. This says compounded annually, so it's not continuous. So it's going to be 1 plus R to the power of t is going to be equal to the ending value, okay? Well, in this case, R is 0.067, so 1 plus 0.067 is 1.067. T in this case is 35, so we're going to say to the power of 35 And we don't know the starting value. I think that's what they want us to solve for. What is the starting value? In fact, how much do you need to invest? That's right, that's starting. That's going to be equal to the ending value, which is 80,000. And so it looks to me like we can just divide. If we're solving for the starting value, all we have to do to solve for the starting value is divide by this exponential expression. Divide by 1.067 to the power of 35. If we divide by that on both sides, 1.067 to the power of 35, it's going to cancel on the left side, and all we're going to have is the starting value. So the starting value is equal to 80,000 divided by 1.067 to the power of 35, which we can do in the calculator. So we can do 80,000 divided by 1.067 to the power of 35. If I press enter, I get 8266 point. Now this is money, so we're going to stop in pennies. We got 0.759. That 59 becomes a 6. So it's 76 cents. So $8,266.76. 8266.76. So 8266. This is in dollars. 76. So that is how much money we need to invest to get $80,000 after 35 years at a rate of 6.7%. All right, question 16 here says if $5,000 is invested, that sounds like a starting value to me. It's invested in a bank account at an interest rate of 7% per year, compounded continuously. That means we're going to need to use the letter E. Then how many years? So we're solving for time. How many years will it take for your balance to reach $100,000? Okay, so what's our rate going to be? Well, our rate is 7%. And that's going to be 7 divided by 100, which is 0.07. And our formula is going to be starting value, so P sub 0 at e to the power of r times t is equal to P at time t. Okay, and PT, that's the ending value. That's 100,000. Starting value, P0, is 5,000. So we're going to have 5,000 e to the power of r. R is 0.07. 0.07 t, because we're solving for t, is equal to the ending value, which is 100,000. So the first thing we're going to do is divide by 5,000 because we need to get this exponential expression by itself. So we'll divide by 5,000 on both sides. And 100,000 divided by 5,000 is 20. So we'll cancel the 5,000. We're going to have e to the power of 0.07t is equal to 20. Okay. Now, to cancel this e, we're going to have to do the natural log of both sides. So I'm going to come up over here, and we'll do the natural log of e to the power of 0.07t is equal to the natural log of 20. Natural log of e will cancel, and we get 0.07t is equal to the natural log of 20. All set? Awesome. Thanks, man. And all we have to do here now to solve for t is just divide by 0.07. 0.07. 0.07 cancels. And our final answer, well, we're going to put it in a calculator, but it's t equals the natural log of 20 divided by 0.07. And let's go to the calculator. Natural log of 20 divided by 0.07. And that's going to give us 42.796 years. So 42.796 years. And that is our solution for time. All right, here's our last question for this group. It says a population begins with 40,000 members. Well, that's our starting population, 40,000. Says that it grows. So it's a growth formula at a continuous annual rate. That means we're going to use E. And the annual rate is 3.19%. So that means R is going to be equal to 3.19 divided by 100. which is going to be 0.0319. So we've got our R, we've got our starting value. We know we're going to use E. So it's going to be e to the power of rate, which is 0.0319. And then it says, what is the population after 8 years? So they gave us the time, that's 8, and they're asking us for the ending value. And so this is actually pretty easy because this doesn't require any algebra at all. All we have to do is key in this calculation into the calculator. So 40,000 e to the power of 0.0319 times 8. So 40,000 e to the power of, what was that, 0.0319? 0.0319 times 8. And then just press enter. And we get 51,628.79. Now listen, this is a population. Well, we don't know for sure that it's people or deer or, squirrels or whatever. So we're going to go ahead and round it to 3 decimal places, but if the question tells us to round to the nearest whole number, which we often do with populations, it would be 51,629. But we'll go ahead and write 51,628.79 because this 5 rounds the 9 up to a 10. This would become a 0. This 8 would become a 9. So 79. So 51,628. 628.79. But if we were told to round to the nearest whole number, it would be 51,629. So either one of these would be a reasonable answer. And that's it for the exponential applications.